Last week we learned how to divide polynomials using what's called synthetic division. And starting today, we're going to use that same thing. We're going to use synthetic division, but we're actually going to use it to factor polynomials. So I'm going to start off with an example today for two reasons. Number one, I want to review synthetic division with you, and also it's going to lead into learning how we can use this to factor. So if I wanted to do synthetic division, I would set up like this. This is our synthetic division bar. And then we look at the first polynomial, the one that's usually a higher power of x, and we write in its coefficients. So we start off with an x squared, which means 1x squared. So I'm going to start off with a positive 1. And then we have minus 7x, so I'm going to put a negative 7. And then we have a plus 10, so I'm going to put a positive 10. Now the next thing we do is we look at this number here from the factor, but we change the sign on it, and that's what goes out front. So since my factor is x minus 2, I'm going to change the sign and put a positive 2 out front. Okay, so the question's all set up and we're ready to do the work. Here's how synthetic division works. The first number always drops straight down, so the 1 just comes straight down. Then, to get back up, you always multiply by that number out front. So I do 2 times 1 is 2, and I put a 2 right here. And then I add. Negative 7 plus 2 is negative 5. And then we multiply to get back up again. 2 times negative 5 is negative 10. And then we add. 10 plus negative 10 is 0. Now here's how we read our answer. We look at the original one we were dividing. The highest power of x in that one was x squared. After you do synthetic division, it always lowers it by 1. So if I started with an x squared, then my answer starts with an x to the first power, or just an x. And then you go down from there. After the x term comes your constant term, or your number, and after that comes the remainder. Now, anytime you get a 0 for any of these, you can just throw them out. So this question actually does not have a remainder. We'll ignore that. But what I have is 1x, or x, minus 5. So the answer to this question is x minus 5. The answer to the question, x squared minus 7x plus 10 divided by x minus 2 is x minus 5. All right, that was a review of synthetic division, but it's also, like I said, going to lead into what we're going to do today. So here's what we just did. This is the summary of our example. X squared minus 7x plus 10 divided by x minus 2 equals x minus 5. Now, you can turn any division problem into multiplication by flipping it, because those are inverses. So let me go off to the side here and show you with numbers. I think it makes a little bit more sense if I show you with numbers. If I make up a quick division problem, something like 21 divided by 7 equals 3. That's true. 21 divided by 7 does equal 3. But if I wanted to flip that around, what I could do is work it backwards. I could say 3 times 7 equals 21, which is also true. So think of it like this. The big polynomial here, that was our 21. And then we divided it by x minus 2. Let's say that's the 7. And our answer was x minus 5. I'll put parentheses around it so it looks the same. Our answer was x minus 5. That's basically like the 3. So if I flip it around, then 3, or x minus 5, times 7, x minus 2, equals the big polynomial. Now if you notice, what we've actually done is we factored it, because we started with this one, and we turned it into what we call factored form. So that's how we're going to factor. We're going to factor by realizing that dividing polynomials actually is factoring. So here's a couple things for you guys to remember from synthetic division. Number one, that very last number in your row of answers from synthetic division is the remainder. And what's very important when it comes to factoring is that when that last number is 0, like our answer from before, then there is no remainder. And that's really what you're looking for. When you're factoring using synthetic division, you're dividing and you're checking to make sure you get a 0 at the end. You're making sure there's no remainder. So here's how factoring polynomials works. Number one, if you do get a 0 for the remainder, then what's left over for your answer is a factor, or actually the way I worded it here, the one that you are dividing is a factor. And you can write the first polynomial in factored form. So the two factors are, number one, the one that you divided out, and number two, the answer to the question. So let's do this for our first example. We're going to take this division question, 2x squared minus 6x minus 5, and we're going to divide it by x minus 4. And what I'm asking you is, number one, is the x minus 4 a factor? Is the x minus 4 a factor of 2x squared minus 6x minus 5? And what we're really checking there is to see if the remainder is 0. So if the remainder is 0, the answer is yes, it's a factor. And if the remainder is not 0, then the answer is no, it's not. Now, if it is a factor, we're going to finish it off by writing it in factored form, but that'll be the easy part. So let's start this question exactly like the one we did earlier today with synthetic division. So let's set up for synthetic division here. I have 2x squared, so I'll put a positive 2, minus 6x, so I'll put a negative 6, and minus 5, so I'll put a negative 5. And then again, for that number that goes out front, I look here, but I change the sign. So since my factor that I'm dividing is x minus 4, I put a positive 4 right there. And now let's do the work. So the work is the first number always drops straight down, 2. And then to get back up, you multiply by 4, by the red number. So 4 times 2 is 8. And then we add. Negative 6 plus 8 is 2. And then we multiply again. 4 times 2 is 8. Negative 5 plus 8 is positive 3. So the answer to this question is no. X minus 4 is not a factor. Remember, if it was a factor, we would have to get a 0 at the end. So if you get a 0 for the remainder, then it's a factor. If you get any other number, we got a positive 3 here, it's not a 0, then it's not a factor. So that's what we're doing, and we're done with this question. That's our answer, is no. X minus 4 was not a factor. So let's try another example, the exact same directions, but different functions this time. So let's start it the same way. I'm going to set up for synthetic division. We have a 3x squared plus 11x, so I'll put positive 11, and minus 20, so I'll put negative 20. For my number out front, I change the sign right here. Factor is x plus 5, so I put negative 5. And we'll do our synthetic division. First number always drops straight down, that's a 3. To get back up, we multiply by the red number. So negative 5 times 3 would be negative 15, and then you add. 11 plus negative 15 is negative 4, and you multiply again. Negative 5 times negative 4 is positive 20, and when you add, you get 0. Negative 20 and positive 20 give you 0. So the first answer to this question is yes. X plus 5 is a factor. Now, there is a second part to the question. We didn't have to do it on the first one because if the answer is no, it's no. But it says if it is a factor, write the polynomial in factored form. So the answer to the question in factored form is the two factors. Now, one of them is x plus 5. As soon as we realize that x plus 5 is a factor, that's one of our factors. To figure out the other one, we go back and answer the question. So we go back to our synthetic division. I look back at my original problem and it started with x squared. We lower that by 1, my answer starts with x. That makes this the number part, the negative 4. The 0 would be the remainder, but remember when you have a 0, it just disappears. And those together give you the other part of your answer. So my other factor is 3x minus 4. And that is the original polynomial in factored form. So if I ask you to factor 3x squared plus 11x minus 20, which I did, the answer is it's x plus 5 times 3x minus 4. And we figured that out using synthetic division because when we divided by x plus 5, we didn't get a remainder, and the answer was the other factor, 3x minus 4.